In this lesson, we'll implement the complete update of our grid. After we clear up the chains, blocks need to fall and cover the remaining spaces, and then blocks from the reserve need to fall in and cover whichever spaces were left, so that we actually have the full match 3 functionality working on our console. The method is called update, and basically all it does, it moves down blocks to fill in empty slots. How is this gonna go? We're gonna start going through we're gonna go through all of the rows starting from below. Every time that we find a 0, then we'll climb up on that column until we find the first non-zero value, and then we'll make that fall. And then we keep on going, we'll keep on filling all the zeros and dropping elements all the way to the top, and then if there are zeros here, we'll drop elements from here. At any point in time, we'll be dropping elements from there as needed. So for example, if here's a 0 and then there's zeros all the way to here, then we'll grab this number and drop it all the way here. So let's get started. match3.board.prototype.update grid function. We'll need some variables I, j, k, and found block to keep track whether we found a block or not. So we need to start go through all the rows from the bottom up. For I equals these dot rows, that's the total number of rows minus 1, all the way to 0, so all the way to the top, and subtracting 1 on each iteration to make it climb up. So every time in each case we need to go through all of the columns. So we're going through all the rows, and now we need to go through all the elements in the columns, right? So just like we iterated with A, we also need to iterate from J from the left to the right. There's no need to do it backwards in this case. J++. So that's the same thing we've been doing all along to go through all the columns. Now, if the block is 0, then get the first non-zero, then climb up to get a non-zero one, so that it falls on top. So if the element in position I and j equals to 0, and we use the triple equal sign, which only is true when the element has a value of 0 and not false, then found block is false, because we haven't found it yet, we're searching for it. So climb up in the main grid. If we don't find anything, so if still we don't find anything, then we need to climb up in the reserve grid. So this is just to give you the heads up of what's coming next. So let's climb up in the main grid first. Let's use a variable called k, which starts in the position up of the current one. So if we were here, k will start here and keep on looking up. K goes all the way to the top, just like I, and is subtracted in each iteration. So this, what happened here is we found a 0, and then we keep going up to find a non-zero value. So if we find a non-zero value, if grid located in position kj is greater than 0, then we need to drop the block that was on this position k into position I, our current position, in the column we're currently in. We've already implemented drop a block, sorry. Also, found block is now true, and we need to quit this iteration. We need to leave this iteration because we found the block, and then this will not be called. But what happened if we went all the way to the top and it was all 0, 0, 0, 0? We've reached now the reserve. We need to access the reserve. So that's when that happens here. And that works in a very similar way to this, but just slightly different. So instead of starting in this position, we need to start at the base of the reserve. The base of the reserve is this dot reserve row minus 1. And we start from here and we climb all the way to here. So we keep this the same. Then we're no longer looking in grid, we're looking in reserve grid. And if we find something, we need to drop it. We need to do a drop reserve block, not a drop block. And there's no need to keep track of found block because we will find one for sure because we have enough. We have enough to do that. Let's check this current implementation. Let's firstly clear all the chains. So as you can see now, we have a lot of empty elements. And actually, I've just noticed that it could happen that we have more than 5 elements in the reserve. It is unlikely, but it could happen. So there was that little error in here. And actually, reserve row should have as many rows as the actual main grid. So that's not going to change anything else. That's why we did it as a constant. So I hadn't noticed that before, even with the finished game that I've already created. So, okay, so let's maybe refresh that to avoid that happening again, that we don't have enough to cover. Okay, so now we have say all of these zeros, and we want to cover them with this. So we can call now update grid, and if you look at that again, see how these 4 zeros were filled out with 7242. So you have here 7242, and also more elements that came from above. These 3 elements that went down, and then elements from the reserve went down. So the reserve has been used. There's a lot of zeros here now. All of that covered the holes. So what if we want to do another update? If we found new matches and we want to clear those and that sort of thing. Then we would run into problems. So we need to repopulate the reserve after each update. So after every time we call this, we have to repopulate the reserve so that it never fails us. Populate reserve grid. And there you go. So now if we do that again, you'll have a few chains to cover. But if you do an update now and then a console log, you see that this is always now full, ready to be used again. So then you can do we can do another clear chains. So we have now new things that, well, in this case we didn't get any chains, but if we had, they would have been cleared. So that's actually another thing that I want to change from this game, and it is the way I had originally implemented it, which was to have maximum of 6 variations. Because with 7 variations, you don't get enough. We're not getting enough as I would like. So now we have. Now it's more rare that we'll enter situations where we don't have enough. So to summarize, I was able now to implement the update grid. How does this work? It goes exploring all of the rows starting from the bottom up. Every time a 0 is found, we climb up its column as much as we need to until we find something. In this case, it would be easy. It would be just that would fall in here. And then we keep on looking for zeros. Then we'll find a 0 here, right? Because we just dropped one. And then we'll replace it by that and so forth. And then all the way to this one. So we've got that now happening. We've got a whole match 3 game that we can play via the console, because we can swap. Now we can do swapping, and we can check if it's adjacent, and only swap if it's adjacent, and if a swapping doesn't create a new chain, we can reverse it, and so forth. But now it's time for us, and in the next video forward, to integrate this with Phaser and make it all visual and have user input, so that we have a full match 3 game.